Alright, so yeah, in this video we are going to see the wiring of this drive. Alright, what are the internal wirings? Now you can see here this is a drive and we have wired the circuit here. Okay, so these wires are basically coming to these wires. These are the terminal box. We have extended these wires. The reason is because in this trainer we are using a PLC. Okay, Micrologics 1400 over there. That's the PLC. We have connected the VFD wire relays to the PLC. Basically PLC is turning on the relays. And relays are wired in such a way that if you turn on a relay, these control terminals will be activated. So how this is activated, what do I mean by activated? Let's see that in the detailed wiring diagrams. Okay, so as of now just understand that this PLC is connected to the drive. Okay, so this is the diagram which you generally find in the PLC or VFD manual. Okay, so I have created a modified diagram, not modified but in an interactive way. This is the actual diagram on my trainer. I'm explaining that because I'm going to work on this trainer in another further videos, so I'll be linking my PLC to the drive. So to understand my further lessons, we need to understand this diagram as well. Okay, so let's start from the top. This is the input terminals onto which we have connected line and neutral. And between line and neutral you can also connect your MCBs or a contactor or relays, whatever you want. Okay, so this is all about connecting the inputs, which is 220 volts single phase or 3-phase 220 volt as well. You can do that. This is just an overview. Anyways, yeah, these are the control terminals 1 to 6, 1 to 4. This is the same terminal which I have shown you in previous slides. Yeah, these are the control terminals. Let's see what we have in here. So you'll find on the drive there are some numberings. You cannot see that, but there are some numberings on the bottom. Okay, that numberings you can also see here as well. These 0, 1 to 6 and 11 to 16, these are the numbering. Now these numbers have some meaning. Okay, so the 01 says stop. This is the stop terminal. 02 is start and run. 03 is direction, run, reverse. 04 is a DIG common, digital common. Okay, digital ground or common. 05 is the digital input. 06 is a digital input 2. 1 and 2, these are the external terminal inputs. Okay, just like we have M0 to M5 in that VFD of Delta, this is DIG in 1 and in 2, and you may have more inputs in some other version. In this version we just have 2 inputs. Then you have 11 number, 24 volts, internal 24 volt supply. On 12 number you have 10 volts. On this is the next 13 number. I forgot to mention here, this is the 13 number which has 0 to 10 voltage input. Okay, this is the voltage input terminal on which we have to connect 0 to 10 volt to run the drive in different speed or frequency. This is the analog common. This is the 4 to 20 milliampere input. Now let's see one by one what are these terminals and how I have connected this one. So you'll find some over there. Let me start from here. This is the PLC input card. Now we have connected a PLC input, some terminals of PLC input to relay feedback terminal. Now these 3 terminals R1, R2 and R3, which you may find over here. This R1, R2 and R3, this is a relay. Okay, relay terminals. PLC has an inbuilt relay. If you find here, this is a relay, an Omron relay. Its 3 terminals are there, common, NO and NC. Middle one is common. Okay, so this middle one R2 is common. If you know relay, you might understand what is common, NO and NC. And if you see in this symbol, R1 is NO, R3 is NC. So this common is going to NC. Through R3 it is going to one of my PLC terminal, I:0/19. This is the last PLC input which I have connected to the NC of this drive. Now this relay gives you feedback. Feedback when your drive has a fault, or feedback when your desired frequency is achieved, or a feedback whether the drive is running at 0 to 10 volt or keep it controlled. So we have various types of feedback which comes from the drive. So it's up to you which feedback you want to read. And if you want to read that, one way is you can connect directly some LEDs or indicators next to that, or the other way is you can connect that to PLC. So in my case I have connected this to my last input of PLC, I:0/19, and this is IN6. NO, this is connected to I:0/18. This is connected to my PLC, and to the common I have provided 24 volts. PLC common is 0, so this will be detected. So let me show you a small overview. Yeah, like this. So the NC is already giving you a signal. So IN7, which is I:0/19 in the PLC, is on and this is off. So when this relay is on, this will get on and this will get off. Alright, so if you want to see that in Micrologics, that's the PLC, the ladder diagram, and here we can monitor the inputs. This is the input, and the input which is on is 0015, let me see. That's my 19. Okay, I colon 0/19. This is already on. This is on because my NC terminal is going to IN7. So like this is on. Alright, so yeah, now we have PLC output card, not output card, we can say output terminals as well. Now this drive has to be connected to in two ways. It can be connected as we call it sync wiring and source wiring. So right now it is source wiring. Now what do we mean by that? There's a switch on the drive. If you see this camera, there's a switch over there, small switch over there, which says source and swing. There's a toggle switch. So right now my drive is at source. Now what happens when we connect that to source? We have to connect 11 number, which is a 24 volts, to the input terminals to activate that. That is what source means, because internally these terminals are having some transistors or some internal circuitry which is gets shorted to 0 volt. Alright, so these terminal inside get shorted to 0 volt when you toggle that switch to source in the drive. Okay, when the switch is at source, these are connected to 0 volt internally. So when you connect 24 volt externally, these get activated. So what we have done is our drive is connected in source mode. Okay, in source mode we have connected 11 number directly to one number. This is for stop via one relay NC contact, which is R6. This is my R6. Okay, this relay is connected to O:0/6, which says this is the PLC output. We have this output here as well. This is the output. So what happens if I turn on this one? No matter what is the position of drive, the drive will get stop. Okay, so right now drive is stop. Okay, even if I press run here, this will run. Okay, now right now our drive control is keypad control. That's why you can see this LED. Alright, if you make your control to external control, this LED will be go off, and then you can start and stop the drive using these terminals. Using the terminals which you can see here, yeah, the start run, direction run, DAG in, DAG into. Now there are two ways to run the drive. One is from the keypad, one is from external terminals. When you're going for external terminals, then these terminals are being used. Okay, so during the course I'll be telling you how to connect to these terminals, how to turn on the drive using 02, 03, and how to change the direction. As of now, what we have done is we have connected 24 volts via NO contact to 02, 03, 05, and 06. Now these NO contacts are of the relays which are connected to out 2, out 3, out 4, and out 5. So in a way, if you turn on O:0/2 from the PLC from here, if you turn on this one, it will turn on this contact, it will close this contact, and your 24 will go to pin number 02. Alright, so I'll be explaining you when we are going to start and stop the drive. And our out 3 is connected to 03, out 4 is connected to 05, and out 5 is connected to 06, and our out 6 is connected to stop terminal. Alright, so this was the control terminal to start, stop, and to change the frequency and to run in the jog mode. Alright, this is as of now. And these pair of terminals, here we have a potentiometer to control the speed from external source. So the potentiometer you can also see here. That's the potentiometer. We can also control the speed from this potentiometer. So to do that, we have to connect the frequency, connect the potentiometer to pin number 12, 0, and analog common. So what happens? This analog common is basically 0 volt, and this is 10 volt. So you have 10 volt signal here, and you will get variable 0 to 10 volt signal at the middle point when you rotate that potentiometer, which goes to 0 to 10 V in. I hope that makes sense. This is to control the frequency. Okay. And if you see this 4 to 20 milliampere, this is another terminal to control the frequency if your source is current 4 to 20 milliampere. It can be 0 to 10 volt, it can be 4 to 20 milliampere. So if you're providing current, this is another common for that. It's mutual common for voltage and current. Alright, and then your drive is connected to motor by UVW pin to 3-phase. So this was about how we have wired this drive. We have used a PLC to read the feedback. We have used the PLC outputs to turn on the inputs, to activate the inputs. This is the source wiring. And if you see the sync wiring, there's only one difference. Here 24 is not connected, DIG common is connected. Okay, common will go to the internal this control terminals, and this 24 will go there. Common is not connected. So that was about wiring the drive, how we can wire it in sync and source, and how it's not necessary to use PLC and contacts here. We can use simple switches, toggle switches, NO switches, NC switches, but just to make this course a little more complex and to control that using a PLC, which most of the students are looking forward to, I have personally done this using a PLC to make it more, more knowledgeable and to understand more better. We can make logics here, so parallelly you can also practice PLC logics. It's MagLogic 1400 to control this drive. Alright, thank you.